All right, in this video, we're actually going to start deriving some power series when given a function. So let's say that we have some function f of x, and we're trying to get the power series p of x that corresponds to it. First of all, we need to look at this notation. We say that p sub n of x is equal to c sub 0 plus c sub 1x plus c sub 2x squared plus c sub 3x cubed, and so on, all the way out to c sub n x to the n. We call this an nth degree power series. Now it's nth degree because our last term is to the nth degree or to the nth power. So a third degree power series would stop at c sub 3x cubed. It'd be all these terms up to c sub 3x cubed. And you need to realize that your c's are constants. And really, that's going to be our job, is trying to figure out what those values of c are. So let's say that we want these two functions to be equivalent. So if that's going to be true, if f of x and p sub x are supposed to be equivalent, then the first thing that should be true is that if we pick some value x equals a, then if I put a into f, I should get the same answer if I put a into p. If I take their derivatives, they should have the same value. So f prime of a should be equal to p prime of a. Their second derivatives would be the same, their third derivatives, and so on. So I could continue that process on. So now we're actually going to go through and we're going to find a power series for f of x equals e to the 2x. We want the fourth degree power series, and then we do need to talk about that we are going to expand this about x equals 0. Now that is, back in our previous slide, or in our previous discussion, what our value is. We said at x equals a. Well, 0 is going to be our value of a. All right? So we're going to say, all right, so f of x is e to the 2x. Since we want our fourth degree power series, we'd write that p sub 4x would be c sub 0 plus c1x plus c2x squared plus c3x cubed plus c4x to the fourth. So we're trying to figure out what all those values of c are. So for these to be equivalent functions or equivalent values, what I want to do is put in this x equals 0 into both of these functions. So f of 0 is going to be e to the 0, which would just be 1. And p4 of 0, I'm going to put 0 in for all the x's, is going to give me c sub 0 plus, well, c1x, if x is 0, would just be 0. c2x squared would be 0. c3x cubed would be 0, and c4x to the fourth would be 0. So we now know that if these two are equivalent, I should be able to set f of 0, which was 1, equal to p4 of 0, which was c sub 0. And I now know c sub 0 is 1. Now we're going to look at the derivatives. So if I take the derivative, f prime of x, I get 2 e to the 2x. And if I do p4 prime of x, taking the derivative of this, the derivative of c sub 0 would just be 0. c1x would be c1. The next one would be 2 c2x squared x, and then 3 c3x squared, and 4 c4x cubed. But again, I want to see what happens when I substitute in 0. So f prime of 0 would be 2 e to the 0, which is 2. P prime sub 4 of 0 would be c1. And then all of the rest of your terms have an x with them. So when x is 0, they'll all go to 0, so I would just get c1. So setting f prime equal to p prime, I now know that C1 is 2. So continuing on now, I can find my f double prime of x, which would be 2e to the 2x times another 2. So that would be 4e to the 2x. And then P4 double prime of x would be, well, C1 would go to 0. So it'd be 2C2 plus 6C3x plus 12C4x squared. But putting in 0, f double prime of 0 would be 4. P double prime of 0 would be 2C2. And then all the rest of those would go to 0. So I now know that 4 is equal to 2C2. So C sub 2 would be 2. Now let's move on and take the third derivative. So f triple prime of x would be 8 e to the 2x. P triple prime sub 4 of x would be 6C3 plus 24C4x. F triple prime of 0 would be 8, and P triple prime of 0 would be 6C3. So setting those equal to each other, we'd have 8 equals 6C3 divided by 6, and we get that C3 is 4/3. So now doing the fourth derivative, so our fourth derivative of x would be 16 e to the 2x, and our fourth derivative of P4 of x would be 24 c sub 4. But then if I put in 0, the fourth derivative at 0 would be 16, and our fourth derivative of p at 0 would be 24c4. So then we get 16 is equal to 24c sub 4 divided by 24, and we're going to get that c sub 4, both of those are divisible by 8, would be 2/3. And now we just finish up by putting in all of our values now for C0, C sub 0 through C sub 4. So our fourth degree power series would be given by, remember we said it's C sub 0 plus C sub 1x plus C sub 2x squared, C sub 3x cubed, C sub 4x to the fourth. So going back, our fourth degree power series would be equal to C sub 0 was 1, C sub 1 was 2, C sub 2 was also 2, C sub 3 was 4/3, and C sub 4 was 2/3. And that is our fourth degree power series for e to the 2x. So what we are again saying is that e to the 2x could be modeled by this equation as long as you stayed close to x equals 0. Because remember, 0 was the function that we substituted in, or the value that we substituted in for our a.